Whitesnake. There
Fabulous.
you have it. That's
You
for
had
you,
to get it in.
Stephanie.
You had to get it in.
Yes. Yeah. Oh my
You
gosh.
guys remember that tune? That was like one of the best.
Sing us a few notes there.
Yeah.
No, that's your job. Hey, I want to share something really funny with you. We did the IoT Slam 2020 special IoT Coffee Talk about a week or two ago, right? And you have that little rhythm section with the intro part that I did. So I used this dust off can because I don't have a cowbell like you do, Stephanie. And I got this Sharpie. And listen to this. You hear that? That's
That's awesome.
cool, right? It modulates. It goes
That's cool.
doing, doing, doing.
It probably has to have some of the liquid inside of it.
Yeah. But you can get all kinds of cool sounds with this.
You should audition for Stomp.
Stop.
Vegas, here we come.
Exactly.
Yeah. So hey, Rob, congratulations for being like the Uber influencer, right? On whatever that thing is that you showed us.
Whatever that thing.
Yeah, but apparently
So
you're up
many
there
of
with
them, Rob.
Elon Musk. Oh my God.
I know. That was crazy.
You're an IoT beast. You're a techno beast, man.
You just got to keep showing up and putting out the
Yeah.
content, right?
Yeah.
I mean,
yeah.
that's really what it is. If
Yeah.
you stop, people forget about
Out
you.
of sight, out of mind. Stay real.
Yeah. So
Yeah.
that's that constant drumbeat.
Yeah.
Like what we're doing here, right?
What we need are some honest conversations, and I think that's what we deliver.
Yeah.
So, all right, let's get started.
Absolutely.
Okay, well, I want to give a shout out to two folks who suggested the topic for today, which is IoT security. So, Priya Aswani of Microsoft. So, you're one of your alma maters, Rob, right? And Brett Stephenson of Agile PQ. Both of them, coincidentally, hit me up about 2 weeks ago wanting us to talk about IoT security. And, internally we've been talking about IoT security as well, right? So why don't we get started?
I think that's great.
What do you guys think about, the industry always talks about IoT security, and then you see all these articles talk about, oh my God, IoT security is just horrible, and it's going to be the biggest issue for IoT and 5G and AI and everything else. So why? No one talks about why. They just say that it's horrible.
Well,
Why is it horrible?
we talk about IoT security problems, shortcomings to be one of the biggest blockers to IoT adoption. If we go back to why have we not hit those numbers, there's lots of reasons. And one of them is security. A lot of people are freaked out and paranoid because there's just enough news that comes along every week or every month about some hack attack on IoT devices of whatever kind, and that's a broad category in itself, actually. Just unsecured devices using default passwords. God, the list is so long. And so when you're doing an ROI calculation, I'm doing IoT because I'm going to make money or save money or whatever, a decision maker has to also incorporate the security risk because not to scare anybody, but if you think about it, the Internet of Things represents the largest attack surface in computing history because it's much more vast than PCs, servers, smartphones. There's just so many of them, right? And then it got worse because we decided to connect them, which we thought was a good thing.
Yeah.
It was kind of like it's kind of like going from the good old 90s at Microsoft and Windows and stuff before everything was connected to the internet to as soon as everything got connected, Windows and all these other things were just getting hacked to death because it was not in anyone's mind that they needed to be protected, right? And that's kind of where we are now with IoT, I think, a little bit.
And everyone's trying to pass everything through the cloud. And I think there is a pretty significant difference between the security issues or the risks that we see on the consumer side versus the OT side, right? And, quite honestly, we don't hear about as many hacks and compromises on the OT side, not necessarily because they've progressed so far into adopting, let's say, newer IoT solution paradigms. But there's a lot of brownfield out there, and you rarely do actually hear about them getting hacked. There's occasional reports that come out, but nothing like on the consumer side, right? Consumer side, right. You always hear about everybody getting hacked and, their kids being spied on, crazy stuff.
For sure.
I mean, there's been some pretty big cases out there on the operational side with some manufacturing facilities. The old legacy one was what Target hit when they came through the back door and got into their, they came into the HVAC system, which was their first entrance, and then they eventually got into the payment processing and transaction records because it was connected, the HVACs. Some of the systems were connected operationally to the financial systems, and they just kept popping until they got to that data.
No bueno.
But, I think that the big thing for a lot of scale people that are thinking about IoT projects at scale is if it is critical, operational equipment or operation related, then it's if you're not thinking about security up front and doing all you can up front, then there's just massive risk. So you have to really start to think through, if I do get compromised, if I do get hacked, if someone does physically pull a plug somewhere and causes havoc, what happens then? And so I think that there are tech companies that are getting a little bit smarter about helping kind of alleviate some of that pain and walking through that with customers. And customers are also demanding more of their technology vendors to help guide them through that and have some kind of formal process for risk mitigation, what happens, and having that just real-time information of their assets, just in case there is some kind of breach.
That's a good example, though. The HVAC, I've heard examples going through some small fish aquarium that was connected to get to vital stuff. Obviously, a lot of us, we know hardcore security professionals that's their whole business, and they love to say, hey, like when I say, oh, well, this needs to be air gapped, or we need to put this on a different network segment, or this needs to be private, and they always say, well, that's not a good answer. It's not a good answer for security. You gotta, it's got to be at the device level or whatever. I just want to say, forget about that stuff. It's a layered approach, and you know what, the evidence is showing whether the actual thing you're trying to protect or your POS system or your whatever is secure or not. When you don't connect things to the internet, and when you don't connect vital systems to more public systems, we're just not seeing these hack attacks. Right. When I was at Hitachi and we were building Lumada, one of the reasons that it needed to be portable and run on-prem or wherever had a lot to do with security. There's lots of folks that I run an air-gapped factory and I'm not going to connect it to the internet because that's how you get hacked. Or we make nuclear reactors. Connecting that to the internet is how you get Stuxnet, and it's how you get fired really fast. And so security is always a moving target. The bad guys keep going, and so you're never done, right? But and it's a layered and in-depth type thing, and so you should do everything. And part of that is, if you don't need to connect it to the cloud, then don't connect it to the cloud. Or a similar example to going through the HVAC to get a point of sale and stuff in Target is cars being hacked. When the connectivity into infotainment system is somehow allowed on the same CAN bus to go to vital systems in the car. Those things should never have been connected like that. You remember we all saw that video. It was an example video, I think, with that guy driving a Jeep on the freeway, and they were able to remotely hack the Jeep and slow it down and speed it up and all that kind of stuff. And so that's just another example of taking harmless things like infotainment and somehow allowing it to be on the same network segment as critical stuff, like driving the car.
I say, I was going to add too, is I take, for example, the supermarket. And I've talked with some of the cable operators who want to kind of do it all as well, but along with the carriers is these big supermarkets, they have their point of sale systems running over the internet. They have, and some of them have public Wi-Fi, coffee shops or whatnot. They have other retailers that are within their building as well, especially the larger supermarkets. But they also have services like, where you can go and turn your coins in, Redbox and the coin exchange and all of that. Some of that's run by Cradlepoint, right? Those routers that are on the back of those. But these supermarkets are, they've become smart in realizing that they need to have some private networks, and they need to have completely separate networks from things that are running they're okay to be less secure versus things like transactions and inventory management and operational things. So in some operations or some businesses or some buildings, they have to start kind of siloing different pieces of their architecture. And from an IoT perspective, if you have connected machines or equipment, that are critical, then there are specific much more layering techniques that might be recommended, as Rob suggested. Whereas if it's something that, is really basic and doesn't really require the security, then those need to be completely on a separate network that might be over Wi-Fi or something that's less secure.
Yeah, but a lot of that sounds like bad IT security. It's like a CISO that probably needs to either go and take IT security 101 or maybe hand their job over to one of their subordinates who actually knows this stuff. I mean, you know what I'm saying? It's just some of these issues, they're not necessarily they're implementation issues, design issues versus issues with quote unquote the technology itself, right? But I think one of the perceptions that IoT is less secure is you have, in some instances, especially now as you have vendors going in and working with brownfield customers, trying to help them figure out, well, how do we get all the snazzy new wireless stuff in there so you can have an adaptable factory or manufacturing plant. They're looking at the network, these hardwired Ethernet-based networks, as being insecure just simply because what they're used to and how they define secure networks is much different than the reality of what OT environments have been dealing with for a long time, right? And many of these environments are physically secured. I mean, unless you sneak into the factory, there's no way that you're going to sit there and hack any of the machines, because these things are all hardwired and you're not broadcasting the network everywhere and creating additional threat vectors that way to your network. And so I think, I think a lot of what's being published is sort of a reaction of some of the folks who are not quite are new to these new customer domains, going, oh my God, look, these guys don't do this, and we do this on the IT side. Oh, these guys on the OT side, they're ready to get hacked and all kinds of disaster stuff's going to happen. But I don't know. I think some of it is like a perception problem. But that doesn't mean that if you go and start to use wireless technologies to hook up things in your shop floor, that you're not going to be introducing additional security concerns.
There are some really good sounding boards that are out there today. I know that the NIST cybersecurity framework that's out there is one of them, right? Mm-hmm. That one actually, they're really working to foster more of the operational technology security, things that are connected, smart building, intelligent building, industrial IoT use cases. But that's a great kind of sounding board to really, where do I start? And also making sure that the vendors are following that framework. So I highly recommend Googling that, looking that up, and maybe reading some of the materials, because it's not only an organization that's really fostering, the whole concept and some of the ideas around how do we really push security, but it's also being fed from different organizations, companies, industrial companies, manufacturing facilities, the equipment manufacturers that are all involved with that organization that are putting their input into that NIST cybersecurity framework. But that's highly focused on the cyber part of security. I like to take a step back when you think about IoT security and think about the network, right? Think about things that are hackable. If you're pushing things out to the cloud. So all of those are kind of more of things that are running over IP, internet, right, based. And then you also have, if you're running things over a wired network, what are the compromises and risks there? And then if it's satellite, there's different things that are compromised there. If it's physical security, meaning that the equipment, especially when you think about smart cities, you have sensors, cameras, whatever that's out in the open. What are the risks involved there if someone pulls a plug or plugs into the back of a router? So there's a lot of little small intricate things that you have to think about that I don't think that whenever we were just plugging in our computer that we really thought about, because it was just so individualized. Now that we have assets that are all over the place, whether they're in a building and secure or out in the open in public, there are different kind of risks and mitigation kind of techniques that we have to consider as we start to connect things and scale. Sorry, dog in the background.
Up a really good point, and oddly, we don't talk a lot about it when we talk about IoT security, which is power. All you have to do in a smart home is basically go to the switch box and turn off all the power, and there goes all your security, there goes everything. Unless
you have a backup.
Unless you have a backup, of course. Right. But, unless you have solar and
UPS.
But even then, no, you can turn everything off. I think you can override stuff.
Yeah. Do you guys remember the Mirai Botnet from 2018?
Yes.
So it and that's what a lot of decision makers point to sometimes is, wow, we had all these IoT devices that were, and it's usually the device, the endpoint, that is the weak link, I find most often. And so you had all these kind of devices or routers or cameras that either had no password or the default factory password. And all of a sudden we had this botnet that was just firing distributed denial of service attacks all over the internet from IoT things. What a nightmare that was. And I think California led the way, passing some bills at least a year, if not more, ago, about at least requiring a minimum level of security around IoT things, at least. I don't know how all that's going around the rest of the world, but that's a deal. So aside from that, the hardware, the thing itself that's have actuators and sensors and stuff like that. There's some steps, like if you're building this technology, because I had lived it a few times. Some of the concepts you did, like from the device side, was always obviously you're connecting it, but the software part of the connecting it always needs to be an outbound only connection. A real fallacy, if you want to, a lot of times people want to send a control command to a device to change its behavior or whatever. But the wrong way to do it is to have software listening on that device for you to send a command. It may seem like the logical thing to do, but just imagine, well, now let's put a web server on your thing. And then that's how it increases the attack surface. And so most really good IoT systems, like if you want to connect to a given platform, it kind of follows the pattern of the device creates an outbound connection to whatever the platform they're using, the customer happens to be using, whatever it is. And it could be REST or MQTT or whatever, but it's never listening. And so outbound's good enough. You're sending telemetry to whatever, to the cloud, to an on-prem platform. But if a platform needs to send a command to the device, you're still good a number of ways. If you're using WebSockets or MQTT or something like that, or AMQP or one of these other words, kind of a nailed up connection all the time, I create it from the device, but I can pass data down that same connection that was initiated by the device. Whereas the device is not listening and spawning new threads or connections for incoming commands. And so that's always a good way to go. If your device is using REST, it might use WebSockets to receive commands, or you can just go to old-fashioned polling, where the device just asks every once in a while, "Hey, you got anything new for me?" or whatever. But it starts there. Other on-device things, you hear terms like hardware root of trust. You hear about TPM, trusted platform module, TPM chips on devices. Qualcomm's equivalent in their stuff is the trust zone. But storing those credentials, because what I would see, unfortunately, on IoT devices is that device needs to connect to a platform, and it needs to pass along its unique identifier and a security token or whatever. And someone would they would either hard code that in to the device, or there'd be a text file or something on the device itself with that information in order to connect. And so that's no bueno. And so the answer, for storing credentials that allows the device to connect, those things need to be stored in hardware, in those TPM chips or trust zones.
Yeah, so we have soft SIMs, eSIMs as well now to tinker with, right? And in some pretty constrained devices as well. And that was one of the things that I know Brent was interested in hearing us talk about, security on constrained devices, right? Where you either have a really light version of an OS running on a microcontroller, even maybe even less, or RTOS. So I mean, what do you have any wise words to share with Brent on that?
That's always been a problem. The more constrained the device is, it's the notion: is the device capable with its CPU and RAM and whatever can it support crypto? And can it create an SSL tunnel? We're not even talking about VPNs. It's just, can I create, a TLS tunnel? And so that used to be a big problem. It's less so today. Moore's law is helping us. While I'll say something controversial, while Moore's law seemed to run out of gas on PCs and servers about 5 years ago, at least it's helping little tiny IoT devices. They are getting more powerful for the same kind of power output envelope, and battery usage and stuff like that. And so I remember there was a company, Wolf SSL was a good vendor that could do SSL on really teeny devices with very low power. That's gotten more widespread, that kind of capability, because you're right, at a minimum. And I know, and the thing is customers are going to go look for these devices, and they need to have a checklist, and it may disqualify lots of devices, and I can see how that could lead to frustration. Saying my device needs to have some kind of secure element in it to store credentials. My device must be able and provable to support crypto, because that same secure element, like a TPM chip, it's what allows your laptop to, like if you're using Windows, it's called BitLocker, and a Mac OS your drives are encrypted. Your iPhone is encrypted by default. And so those secure elements, those chips support that encryption. So the volume, the hard drive, whatever you want to call it, that needs to be encrypted, store credentials securely in the hardware. Got to be able to create a crypto tunnel. So you need to be able to create, TLS, and we're now on TLS version 1.3. because older versions keep getting hacked and we keep finding they're not good enough. And so you need to support that too. And so as a customer kind of walking through that stuff, that's kind of like your checklist. And it's like when you're talking to a vendor, does your device support all these things? And then the IoT platform, am I going to be capable of just doing an outbound only connection to get everything done that I need to do? And so that's just kind of the device side. And then you've got what all the other stuff? Am I going through an edge gateway? And am I doing edge compute? Am I doing on-prem compute in the fog or whatever that used to be, and a cloud? And so encryption all the way through could be SSL. That's what most people are using, right, to get places. It could be a VPN. Once you're doing inter-server communication, is it some kind of IPsec thing? Are all the servers, the cloud servers, the whatever, is the data encrypted at rest there as well, in addition to in transit? There's so many hops and so many points along the way where security could kind of break open for a moment and an attack vector could present itself, right?
Yeah.
So keeping that locked down. And so your IoT platform, when it's listening, and again, it could be a local edge thing, or it could be a cloud thing, or both. Yeah. It's intercepting that incoming connection, and it's like looking at either a header in a HTTP, or whatever, and it's like looking, what's your unique identifier? Let me do my lookup in my system. Do I know who you are? Oh, yeah, I do. And then it's just like people with usernames and passwords, right? Or X509 certificates. A lot of people will happen to use those on devices as well. And then if you're good to go, then I can, if I can authenticate you, then I can authorize to bring you into the big system and drop you in a queue or a database, and then you start doing your processing. But all along the path, it's got to be encrypted and authenticated and all that stuff over and over and over again to be really, really locked down.
Yeah.
Well, I have a question for you guys. So some of the advancements, you were talking about the form factor and really the advancements being made at the device level. I want to get your feedback, especially you, Rob, around the chipsets. So the chipset technology and some of the security at the chip level, you have this hierarchy. And my question really is more of, should we be focused on a bottoms-up approach to security or a top-down approach? Looking at, if you're building something brand new, I can see where a bottoms-up approach might be easier. But what if you already have things out there in the field and you're really starting to clean up your security? What would be the approach? And then, do you hold some of your equipment vendors and some of that, do we have the level of expertise to understand what's in that device, what's in that piece of equipment, what's in that hardware, all the way down to the chipset level to really help us with security? I know that's a loaded question, but
it's super loaded. But it's the world that we live in, because the checklist I just created for you is representing a greenfield scenario, but most of the world we live in is the world of the present, and then it's all brownfield, and we have to work with what we got. And customers aren't going to rip stuff out and replace it with new stuff necessarily, no matter what you say. So especially in the industrial space, you're talking to old machines, or you're talking to a PLC, you're talking to an MES or whatever, and you don't get to control any of that stuff. And so early on, I'm not saying it's the greatest solution in the world, but since you can't control or change things, then that's kind of where you saw the rise of these edge, gateways and stuff like that. It's gonna, here's my edge thing, and it's gonna talk to whatever's in the factory. And because the factory thing can't go all the way to the cloud, right? Because it's probably using some kind of weird protocol like Modbus, or OPC, or a million others.
Right.
But the thing is your edge gateway is kind of being like your firewall a little bit. This device is untrusted. It's not secure. Never had a problem. The OT folks don't really like the IT folks, because the IT folks brought all these problems on top of them. They were fine in their lockdown areas. And they already had analytics, but it was always a closed loop thing. And so trying to break this open and share the information with the world, it's the world, all right. And so having that edge thing we call them gateways, field gateways, all kinds of things. One of these might be connected to lots of different machines inside a factory or whatever that's still isolated. And it knows these machines have some of them don't have any kind of security. Security wasn't a thought, And so you might connect a serial port and a stream of bits is coming, and you need to interpret what that means. And so this gateway is basically trying to provide security on behalf of these unsecure machines. which is kind of a tricky thing, and it's not the best scenario, but it's what you got, right? And so your cloud or your backend IoT platform, wherever it happens to be, is trusting this gateway, this field edge thing. So the edge thing is kind of vouching for these bad guys, these unsecured devices. So it's pulling data in there. It's doing its encrypted at rest here. It's encrypted outbound. It's authenticating, because there's multiple authentication. This one's saying, hey, this machine that's totally mindless, I'm calling this machine 123, and I'm going to give it's a security token, but I'm doing it on behalf of. It's kind of like delegated security. And so when I'm going to check everything, make sure that this thing's not hackable. I may get the answers to your questions actually on this edge device and never go to the cloud potentially. But if I do pass things along, the cloud is just trusting this guy and knowing that it did a lot of work and processing to make sure that hackable stuff's not coming out. And then likewise, where the hacks actually really happen is coming the other direction, a command. And so the edge gateway is also outbound only to the cloud or wherever. It's not listening. And so it does an outbound connection. It has no listening capability. It's got its own firewall and all that stuff anyway. And so there's no way you can send a command and then pass the command through to the machine to disrupt that or something like that. Or, so it's all pretty well orchestrated. And so your edge gateway is a critical part of securing unsecure devices and kind of orchestrating that pass through. How might I send a command to change the behavior of a machine? Something like that.
Well, I was going to say too, is when I think about IoT security, and you just made my mind started wondering about the impact of a breach. I think it's one thing when it happens to your back office or your operations. I think it's another thing when it compromises customer, patient, citizen information and security. Not just data. We have the whole privacy issue there. We have the whole HIPAA requirements that are in healthcare. We have, electronic logging requirements in automotive or fleet. We have, finance. If you're in the securities or the stock exchange, there's some requirements around that exchange of data not being open, right? And I think that every industry kind of also has their own specific requirements in terms of security as a whole. And so I think there's two sides. There's stuff that's happening before it even gets to the customer, and then there's stuff that's client or customer facing. And so I'm wondering, with the breaches that are happening, if we get to a point to where it's just extremely compromising our customers or end customers, then we're going to be even in more trouble as opposed to just things that are happening in the back office we can hide. Companies and corporations are not talking about that. And you asked about that question while we're doing a lot of the consumer stuff. Yeah. But businesses are getting hacked every day. They're not going to be open to sharing that information, right? But when it happens to the end customer, that's when it hits the media. That's when it hits the press. And that's why we hear so much about it, especially the finance breaches that happen, right?
Yeah.
But I'd love to hear your perspective around, right now, I think most of the concern for now in the industry is operational, right? Things that are happening that are going to impact, I'm shut down for the day, or, everything's compromised and I've got to rework everything versus, okay, like what happened with Zoom yesterday. Okay. Or what is it, Monday, or is it yesterday? No one could get online. There was a complete shutdown.
Right.
And so what happens then? And of course, that's one example that's not necessarily IoT related, but the loss of revenue, the amount of dissatisfaction that happens immediately, and what that does, it impact your brand and your company quickly.
Absolutely.
Greyhound. Battlestar Galactica. Just go all analog. Forget all this digital stuff.
Sometimes you do. You want to go back there.
People are the best.
There's still companies out there making cars, and they do everything on paper still. And they think that this digital transformation thing is a pathway to hell.
Safety stock on paper.
Yeah.
Manually calculating safety stock.
Right. Absolutely. Yeah, because it's funny. In the same time that we want to use IoT and analytics to, predict failures or at least nip them in a bud, and so you like a factory making cars, and you don't want that industrial robot to go down, because then, like you said, the line goes down and then it's costing me several $100,000 an hour that I'm down. But you're bringing up the flip side of that. I'm using IoT stuff because I'm trying to prevent this bad stuff from happening, but I exposed myself, and now bad guys are making my industrial robots going down, and I'm still losing $300K an hour.
Yeah, the Cylons are hacking the Cylons.
Exactly. I think that's what everybody typically imagines in their mind, is Cylons attacking Cylons. That's really what it comes down to. I think that's the big takeaway here. It's so serious. It's not for the faint of heart. And so as people who make devices, as people who make systems, as people who make networks, it's one of our favorite people of all time, Andy Grove, always said, only the paranoid survive. Yeah. And, you've got to be paranoid out of your mind for all this stuff. Yeah. Of course, when you tell a customer, here's this giant laundry list and you got to be paranoid about when you're trying to help them, it also probably causes them to take a little pause too. Yeah. And they go, oh, I got to do all these things? Mm-hmm. Forget about it,
Yeah, they see dollar signs. They're like, maybe I shouldn't get going. Do you know the good news that I am hearing right now? And this is good news for the IoT industry. And that is, across the board, everyone that I'm speaking to right now that's in the IoT market ecosystem that's operating out there, coronavirus is escalating, is pushing folks to move quicker and faster, because they're living in a virtual digital operating environment, and they're like, what can we do now? So those use cases that they were all looking at, they're getting serious about, and I think that's kind of pushing them to go ahead and get things. Sorry, I got a jet flying over right now. Hear it?
Yeah, it's not that bad.
But I think it's escalating. I'm seeing a lot of projects, a lot of movement. I'm not seeing a slowdown in IoT. And so maybe this whole IoT security thing, it's coming. I mean, it has to be part of that conversation, but they're willing to make that investment right now because they see that if they don't, they may not be able to operate or have the manual labor that they normally would have in their operation. Yeah. And they don't know what's going to happen next year. So it's like, I'm willing to take the risk now. And I'm seeing a lot of really exciting things happening in IoT because of that. So maybe coronavirus is a little bit of a push for our IoT industry in terms of, what do I need to automate? What do I need to offload? What do I need to start looking at right now? And we're seeing it. I don't know about you guys, but I'm hearing a lot of buzz right now in the last 60 days about
really?
Big things happening.
That's good.
I'm seeing a bit of softness. I'm not seeing as much momentum as you're seeing, Stephanie. But, we're in different parts of the country, and
California's slow. Hey,
I mean, maybe I'm talking specifically in the U.S. But I'm sorry, what was that?
I said California is a little slow. I'm sorry.
Yeah, we are.
Just joking.
Can't keep up with Texas.
Don't mess with Texas. Yeah, the primary value proposition of IoT, which is really, especially for large enterprises, which is 7 Sigma, going beyond 6 Sigma with IoT, that really needs to be balanced and considered against the expanded security threat that you might be introducing or exposing your enterprise to. I think that really is something that folks need to think about, not just looking at, oh, hey, we can improve our productivity by 1.2%. You also have to consider what that's going to cost you in terms of security. And neglecting the security is a big no-no, because especially as you see some of these IoT use cases really imply cross-domain solutions that will go through, let's say, your private network, through a carrier's network, through maybe a neutral hosts network, and God knows where else. Maybe it'll even land on Facebook somewhere. You have to trace all that stuff. You have to, as an architect, you have to be cognizant of where that data can travel. And like what you're saying, Rob, going through that checklist and making sure that the data is secure at rest, in transit, and that is being processed by trusted devices, whether it's a server, it's an endpoint, or what have you. But then also, whoever's using a device is an authenticated user, whether you do that through metrics or whatever.
And that's the big reason, Leonard, that this is an OT nightmare, because all of these things that are happening on the OT side, this is really an IT issue or expertise level that OT doesn't generally have or even want to have. And so I think you have to be careful. I think a lot of folks working with IoT partners or starting to deploy, they're just assuming that the vendor that they're working with has that IoT security piece in as part of that solution. And guys, some of them do, some of them don't. You got to do your homework. And there are also IoT security companies that are out there. That's all they do. And you may need to use that third-party expertise on top of working with the big carriers and the equipment and hardware providers, because you need that added layer of security. I mean, there's just a lot of kind of things to consider, but don't sell yourself short that there are experts out there if you don't have that internal expertise. There are people out there that do this well.
But
you're absolutely right.
Yeah, but match the expertise with the scope of your solution. If it crosses multiple domains, you're probably going to have to talk to several experts, and then have a really good architect who can basically bridge those different expertises, is that a word, together to give you that holistic strategy. Otherwise, you're going to have holes, right?
Yeah.
I mean, a lot of the common breaches is just, okay, the CISO didn't harden the environment. That's like one-on-one stuff. It's stupid.
Absolutely.
I shouldn't use the term stupid, but
stupid, crazy, stupid, silly.
Yeah.
You guys are triggering me. Oh my God. So many stupid microaggressions. I don't know what to do. Hey,
you're going to have to save it for next time because I'm out of coffee and Rick's not here. We don't have Mark and we don't have David, and we know that those guys want to get a piece of this IoT security.
We'll have to do a part 2. We definitely will.
We have to.
Didn't we do IoT security before? I felt like we had.
No.
A long time ago.
Maybe.
No?
Yeah, years ago. Years ago.
15 episodes ago.
Yeah, it was back when we did episode 743, I think. Is when we talked about, and also, don't forget about security. You don't have to hack the whole IT part to break in. Yeah. This is the oldest example in the IoT world, but it's worth being a dork and using it. If you've got a system that's using temperature sensors and passing data through it, and it's going to go through some analytics or threshold and trigger an action, then that whole thing can be hackable without getting into the system. All it takes is someone with a cigarette lighter putting it next to the temperature sensor, and then that sends valid data, authenticated data, encrypted data all the way to your system to turn on the sprinkler system in your building, and then everybody gets wet.
We have the day off now. Yes.
Just pull the plug. Just pull the plug.
Yeah.
You don't even need the lighter, just pull the plug.
But this is also why, after you've done all the things that we think of as security, we start adding in anomaly detection.
I'm so sorry.
And not just anomaly detection like you're normally thinking, but is it normal for us to have this weird spike in temperature out of nowhere like that? Or am I being hacked right now?
Yeah.
And so sometimes you can do that with like streaming analytics windowing, where I say, hey, if I get that spike in heat, it doesn't mean I'm going to trigger the sprinkler system. Yeah. I need the spike in heat lasting for 1 minute or 5 minutes before I do something. Yeah. Or people are using machine learning in many cases to do that kind of stuff. Because with IoT, it's all about this analog world going to digital and sensors, and it's not controlled by humans. And so all kinds of ways to trip up your analytics and your platform, doing crazy, nefarious things.
Okay, so who wants to take us out?
I'll take us out.
Okay.
So I guess the short summary is you can't do it all. There are experts out there. You need to have a layered approach. And after you're done with that layered approach, you need to do all the what ifs. You need to go out to these experts and find out, how can you help me? Push your vendors harder. And we're going to do a part 2 on this, right? So Stay tuned for our part 2. Visit us at iotcoffeetalk.com to see all of our episodes, and we'll get this one posted soon. Follow us at IoT Coffee Talk on Twitter. And make sure you join us on the LinkedIn page as well, IoT Coffee Talk. Thanks,
Thank you so
everyone.
much.
Until next week.
Awesome. Bye.
Bye.